Greetings, Statesman. We have lesson 10.2 for finding arc measures. First thing that we need to discuss is within a circle, we're going to actually measure the degrees of this thing. So take a circle. Of course, you guys have your compass where you're going to construct this, putting the needle down and then encircling to get all the points on the circle. The sum of measures of central angles with no interior points within a circle is 360 degrees. So this is what we mean by that. So let's go ahead and construct this and figure out what a central angle is. So from the center, right, center, you're going to create utilizing radii. So you can see here, I've created an angle again, right? So we're going to have two line segments that are going to share a vertex at a single point. In this case, that vertex will happen at the center. Here, this is an angle at the center called a central angle. The sum of all of these guys will be 360 degrees total for all circles. All right, so continuing on here. Let's do a problem. Got a circle T. And I'm going to have a number of radii and a diameter. So chord through the center. They're going to result. All right, so I've got circle T, and I've got all these other radii that are coming out. These are Q, R, S. Oops, we already have T. U, and V. Okay, so here's what we're given, is that this is circle T. That RV is a diameter. So yes, it does go through the center. All the rest are going to be our points, right? Or are going to be, points on the circle, Q, S, and U, which are going to connect to the point of the center. V, which make them all radii. So we're going to find the measure of angle RTS. Given the following. You guys ready? Here are our angles. First of all, angle RTS is equal to 8x minus 4 degrees. And we want the actual measurement, right? This guy is 13x minus 3 degrees. And we have 5x plus 5 degrees. And then the last one, QTV, is 20x degrees. Now, how would we solve for the measure of RTS? Well, we know this. If the entire interior angle sum is going to be 360, and we have a diameter is going to halve that circle, right? Because it's going to go directly through the center. So then we have two semicircles. So instead of being a total sum of 360, we know that the measure of angle RTS plus the measure of angle STU plus the measure of angle UTV will not equal, right, these three right here will not equal 360, but instead are going to equal half of that 180. Because we have half the circle. So now we can substitute to find x. Once we have x, we plug it back into this expression here, so we can get the measure of RTS. So we have 8x minus 4 plus 13x minus 3 plus 5x plus 5, and that's equal to 180. Now we're going to combine all of our like terms, right? 8x, 13x, and 5x, which is going to be 26x. And then we have negative 4, negative 3, and positive 5, which is minus 2. That's all equal to 180. Add 2 to both sides. So I have 26x is equal to 182. I divide by 26 on both sides, and x is equal to 7, which we're not done, right? Now we need to take that, and we know that the measure of angle RTS is equal to this expression back to here at the top, right? Which is 8x minus 4, and of course we know it's x is equal to, it's 7, right? So this is equal to 52 degrees, right? Where we have 8 times 7 is 56, subtract 4, and that's 52 degrees. Let's get some more notation because we have what are now called arcs that we're going to deal with. So, let's draw a circle. Construct it with your compass, please. And this is circle B. Right? More fun facts about circle B. We need a diameter. We're going to take another radius. All right? So we have A, B, C, right, as an angle. Then here, to end my diameter, I have point E, but I'm going to also add a point between C and E on the right semicircle, which is going to be called point D. We need to discuss arcs. Now, arcs are going to be the length around on the circle, okay? They also will have two corresponding measurements, a length and then also a corresponding central angle measurement from that arc. A minor arc is going to be defined in the following way. A minor arc, and an example of it, is arc AC. So we're going to write AC, but we don't mean a line segment. We have to put a little arc mark above it. So this is something that we need to make sure is going to be part of our vocabulary. The same way that you put a line above a line segment, this is not a line segment, it curves, right, around the circle. All minor arcs are going to have an angle measurement of less than 180 degrees. Next, we have a major arc. A major arc, right, is going to be greater than 180 degrees. Now, here is an example of one. We need to make sure that we give the length, and I can't just say, for example, AC, I'm going to have to give a point additional to get this major arc. So I'm going to give ADC, which means that I don't just take the route directly to C from A. I have to go through D to go all the way around to create this major arc, which of course is going to be greater than 180 degrees in length. Last thing, as I've already alluded to, we have the semicircle. The semicircle, we have two examples here, right? It's not just going to be CE, but we're going to use three letters, so it's arc CDE. Or, of course, we could go this way, right? The one on the left or the one on the right, but we have to clarify, because if we say CE, do we mean this one or this one? They are equal, but they're equal in terms of congruence. Excuse me, they're congruent, but not equal in terms of being just exactly the same thing, right? One is the arc on the right, one's the arc on the left. So CDE is the arc on the right, and the one on the left, right? How would we define that? These 3 points. Of course, it's going to be CAE, and we write the arc mark above it. And its measurement, as I alluded to before in the previous problem, is half of the entire central angle sum, which is 360, and half of that 360 would be 180. All right, so getting to our last two examples here. Here we go. P. This is going to be circle P. But I'm going to draw some other stuff inside of it first. So I'm going to have a diameter here. I'm also going to take a diameter here. And then I'm going to have two other angles that I need to make sure I measure out here. So here's one, which is going to give me a right angle. And then I'm going to have one more between these two radii. And then here are our points K, L, M, and I'm sorry, this is J over here, and then we have O. So here are our givens. We have circle P. We have the measure of angle NPM, which is 46. Moreover, PL bisects angle KPM. And OP is perpendicular to KN, which is marked. I'm looking for three things now. The measure of angle A. I'm sorry, the measure of arc OK. Problem B is the measure of arc LM. And problem C is the measure of arc JKO. Okay. Well, as I said, KN and OP are going to be perpendicular to each other. So OK will be 90. Right? That's our arc. It's going to be a 90-degree arc. It's a quarter of the circle. It's a 360, right? I have LM. What's LM going to be? A few ways to go about this, right? So this guy we need to find. How do we find this arc measurement? We have a few things. We know that NPM here is going to be 46, right? And we know that here's 90 and here's 90, okay? Moreover, we're told that PL is a bisector, so we're trying to find LM, right? So if we can find KM, we can do the rest, right? So 90 plus 90 is 180 plus 46. Uh-oh. Not able to erase these guys. There we go. Okay. 90 plus 90 is 180. It's 46. 226. We're going to back out of 360, right? Which will give us 134. All right. And then we are just going to divide that by 2 since this is bisected. Then that will be 67. Now we're looking for J, K, O all the way around, right? So how are we going to find that? Again, how is this going to be found? Well, effectively, I have here, if I know that this guy's 46, right, with JM and KN, isn't this also going to be 46, right, degrees? Because these are vertical angles. So I'm going to back that out. I have 46, I have 90, that's 46 plus 90 plus the 180, and that's going to give me a total of 316, right? 180, 90, and then the 46. All right. And that's all I'm going to show for right now. We'll talk about arc measure once we get into class for 10.3. All right. So good luck with your homework. If you have any questions, of course, ask me during class or office hours.